Alright, so now this chapter is about the equation of circles in the coordinate geometry. Previously we learned about straight lines. Now in the DSE level we are promoted to circles. Alright. Now the circle equation is like that. If the center is at h and k and the radius is r, then the equation of the circle will be like this: x minus h all square and y minus k all square is r square. Now notice the negative here, alright, so there's x minus h and y minus k, alright, so the center will be at h and k. Now this is what we call the standard form of the equation of circle, the standard form. From here we can directly read the center and the radius, where the center is and how long is the radius. Knowing that once you fix the center and the radius, the circle is fixed. For example, we have an equation x plus 1 all square and y minus 2 all square equals to 4. Alright, so from this standard form, we can directly read the center and the radius. The center will be at minus 1 and 2. Alright, the center is read from here, minus 1 and 2. Not 1 and minus 2, mind you, it's minus 1 and 2 because of the negative here. Alright. And the radius, now, the radius is so easy to mistake to be 4. The radius actually in this case shall be a 2, because the 4 is best understood as 2 square. Alright, the 4 is best understood as 2 square, so the radius is the 2. Alright, so that is the standard form, and how we read the center and the radius from the standard form. Now, if it was like it is like 2x minus 1 all square. There's 2 here. There's a 2 here. Alright. And we have 2y and 3. Alright, all square equals to 1. Alright. So how do you read the center and the radius? Now mind you, the center is no longer 1 minus 3 because of the 2 here. Alright, so first of all, we have to normalize the whole equation to change this 2's into 1's. Alright, to do that we divide not by 4, not by 2, but 4. We divide the whole left hand side by 4. At the same time we also divide the right hand side by 4 so that we don't change anything. Alright, when you divide by 4, now the bracket will become x minus 1 over 2 all square and y and 3 over 2 all square equals to 1/4. Alright, when it is inside the, when you have a squared divided by 4, it becomes a over 2 all square. Alright, so when the 4 enters the bracket, enters the square, it becomes a 2. Alright, so now from here we can read the center will be 1 over 2 and minus 3 over 2. The radius will therefore be 1/2. The radius will be 1 over 2. Alright, so this is about how to read the center and the radius from the standard form. Alright, so this is part 1. Now part 2, when you expand the standard form, you obtain the general form. Alright, let me take this one as an example. Alright, let me start a new page. Alright, so this was the original equation, right? When you expand the brackets, you got what we have, the general form, x squared and y squared and 2x minus 4y and 1 equals to 0. When you expand the bracket, this is what we call the general form. So the standard form is x minus h squared and y minus k squared equals r squared. The general form is x squared and y squared and some x, and we call it d, and some y and some constant equals to 0. So the first one is the standard form, the second one is the general form. Okay, the conversion is that when you have the standard form, you can use expansion to have the standard form. You can have expansion to reach the general form. The other direction from general form to standard form will be the technique of completing squares. Completing squares, alright. Oh, there's one more thing. If you recall, previously we have an equation like this. Alright, let me put it here, right? If the leading coefficient is not a 1, it's a 2, alright? if the original circle is like this, then once again we can do the expansion to obtain the general form. We can expand this, so that would be 4x squared and 4y squared minus 4x and 12y and 9. Alright, you might like to pause to make sure you know how to do the expansion properly. Equals to 0. Now this is a general form, good enough. Alright, it is a circle as long as the coefficient for x squared and y squared, they are the same. It will be a circle. If not, let's say it were 4x squared and 3y squared, then it will not be a circle. Alright, it must be the same. They must be the same. 4x squared and 4y squared. This is a general form, good enough. Or if you want it to look better, you can change to leading coefficient into 1x squared and y squared minus x and 3y, but the constant term will be ugly. That will be 9/4. Alright, but actually they are the same. They are referring to the same circle with the center at 1/2 and minus 3/2, and the radius will be 1/2, just like what we investigated previously. Alright, so this is from the standard form to the general form. We try to do it through the expansion. Now the other way around will be through completing square. Alright, I will show you now. To do the complete square, alright, let me copy this one. It will be a double complete square. We do the completing square on x, and also we do the completing square on y. Alright, so let me take this as an example. Alright, so now first of all, I pull all the x's together, x squared and 2x, and then I pull all the y together, and y squared minus 4y. Alright, the plus 1 is an innocent bystander. Alright, it's here, equals to 0. Alright, so what we're going to do now, we see that in order to complete the square, we need a constant to do that. The constant is the x term, divide by 2 and take the square, so it is a 1. I need a 1 to make a complete square. But at the same time, I have to subtract 1 to balance the equation. Alright, so by similar token, you need a 4 here. Minus 4, divide by 2, and then take the square, so you need a plus 4. But at the same time, you need to minus 4 so as not to upset the balance. Alright, it is still the same equation. Plus 4 minus 4, plus 1 minus 1, they balance each other. But then the first group, you can make it into a complete square. You have x plus 1 all square. Alright, and then the second group, you make another complete square. So we have y minus 2 all square. And then you just collect the constant terms on the other side. You just collect the constant, the red one, the green one, and the purple one. So there's a 4 on the other side. Alright, so this is it. This is the double complete square. We do a complete square on x, we do a completing square on y, and then we collect all the constants. Alright, so we have x plus 1 square and y minus 2 square equals to 4. This is how we convert the general form into the standard form. Alright, so now the second example, if the coefficient is not a 1, if it starts with a 4, alright, it's a matter of your preference towards the idea of completing square. For me, I would always suggest you to use division to convert it into 1, to convert the leading coefficient into a 1. In other words, I would always suggest you divide the whole thing by 4. Also, on the other side, you divide by 4. But 0 divided by 4 is still 0, so it doesn't matter. So we have x squared and y squared minus x and 3y and 9/4 equal to 0. Am I right? Yeah, this is right. Okay, so once again, I try to group the x's together. X squared minus x is one group, y squared and 3y is another group. Alright, the 9/4 is innocent. Alright, so once again, balance. We put the now what do we need here? We need a plus 1/4 here. Alright, in order to balance, in order to make a complete square. But to balance the things out, I have to subtract 1/4 from here. Alright, at the same time, I need the 9/4 here. Alright, so to balance, I minus 9/4. Oh, I forgot the equals 0. Now put it back. Alright, so once again, a double completing square. So we collect everything. We have x minus 1/2 square we have y and 3 over 2, is it 3 over 2? 3 over 2 square, alright? As for the constant, it is 1/4. Alright, so it goes back all the way to our original one. It goes back to our original standard form, or maybe this one. Alright. Okay, so now why do we need a standard form and a general form? The standard form is easier to spot the center and the radius, right? This is the standard form. It will be easier to spot, to find out the center and the radius. This is the general form. The general form is easier for algebraic manipulation. Say when you want to eliminate x, when you want to eliminate y, when you want to find the tangent, so and so, so forth and so on. That the general form is easier for further algebra manipulation. Alright. Now, one final note. If you have problem doing the computing square, if you have problem doing that computing square, we have a formula that can help you. You can find it on the book, right? But actually, I suggest you not to use the formula. It is kind of complicated and confusing. And if you make the mistake, there's no way for you to check it out. But really, if you really want to do the formula, right? The formula is like that. If the circle is x squared now, it must start with 1. If it doesn't start with 1, you have to change it so that it starts with 1. Alright, if it starts with 1, then the center is minus half d minus half e. And the radius will be d squared and e squared minus 4f, no square, right? Minus 4f divided by 4. And everything is taken as square. That is the radius. Alright, if you can remember such formula, then you can skip the computing square. So you can either have it one way or another way. Now there will be an assignment telling you, asking you to do the conversion between the general form and the standard form. So this is the end of this video.